How you doing? Okay, so this is a little, just a quick little tutorial talking about these. I wasn't going to be there today. So here's what do we do with this data? Okay, so we're looking at this data. We're trying to find relationships, right? So first of all, let's take volume. Examine the volume data. If I take a solid, I displace different fluids. The data that gives me, telling me what the volume is that going to change? I pulled here's some data. Halogen table, there was zinc and copper. The zinc, whether it's in volume in water or the volume in air alcohol. Notice that now you might say, well, one person says they're different. Another person says, yeah, but look at that. And what do we know about sig figs? What do we know about this very, very last piece right here? So that's one thing to look at, is that does the volume matter for a solid if I find by fluid displacement, depending on what fluid I use. Now, the other part, we found the masses of these in air, in water, and in alcohol. Notice, here's the mass in air, here's the mass in water. Now, there's a difference. The mass effectively doesn't change, but the scale reads differently, and we call that the apparent loss of mass. So how do I find that? I just subtract the two numbers, and I get the apparent loss of mass in water. This group did a very nice job because they used the right number of sig figs. So you're going to have to show your calculations, pretend I'm stupid, label, numbers, everything. Show me how you came up with that data. And they did the same for alcohol. Here's the mass in alcohol. Here's the mass in air. The apparent loss of mass when we weigh something in alcohol. Now, here's the one people got stuck on. Grams of water displaced and grams of alcohol displaced. This data isn't going to do anything to tell you the grams displaced. What we have to look at down here is go back to the volume data. Look at the zinc, the same volume, right? Got about 9 milliliters. If I put an object that's a solid, you dump it in water, the water goes, 9 milliliters of a fluid goes up. What is the mass of that fluid? The only way I can find that is if I use the density of data. I can convert a volume of water, which is what was pushed aside, to a mass of water using the fact that there's 1 gram for every 1 milliliter of water. So this translates then into about 9 grams is the difference. And if you look, that's about 9 grams displaced for zinc, that is. How does that compare to the apparent loss of mass for water when we do these two? Same thing with the copper, 3.8, 3.9, about there's 3.6. How does the grams of water displaced compare to the apparent loss of mass in the water? Now, excuse me, next one. Got to do the same thing for the alcohol. But remember, if you have a volume of copper and you want to find the volume of alcohol it pushes aside, we've got that. It's about 3.9 milliliters. How do we translate that to grams of alcohol that was pushed aside? You have to look at the density of alcohol. This is the alcohol that was used. You're going to have to go through analyzes and get the density to write sig figs. This is find the grams in each 1 milliliter, and then go back and say, look, if I find the grams of that alcohol displaced by this volume, so here's my copper by about 4 mils, what is that in grams of alcohol? How does that compare to the apparent loss of mass? So again, see if you can answer these questions, okay, and then we'll work on doing some problems. And how can we tie this displacement to maybe make this into a scale without using a scale? That's kind of like a long-range question. Okay, thanks a lot. Hope this helps.